All right, guys, this time we're going to be talking about rotations. That is our unit or lesson 11.3. This is the third rigid transformation we're going to be studying in this chapter, and we're going to end up with this. 11.4 is just a combination of different transformations. So, as for our definition, we can say that a rotation is a transformation in which the figure is turned about a fixed point called the center of rotation. In the figure I am circling in red, you will see the point of rotation is P, and we're going to rotate this figure that at the top has some sort of flag shape. We intend to rotate it in this direction. The one you see is what we call the counterclockwise direction. It's going to be rotated 40 degrees, and as soon as you finish that rotation, it will end up over here. As a rigid transformation, the figure doesn't change its shape or its size. It only, in this case, changes its direction or orientation. If we scroll down, we are going to learn about three different types of rotations today with three specific angles: 90 degrees, 180 degrees, and 270 degrees. So we are going to study those rules. Please take this into account and make sure that it's part of your notes. The rotation for 90 degrees, the original coordinates AB are going to be swapped with the detail that B is going to switch its sign. So if it was negative originally, it's going to end up being positive, and the other way around. For rotation of 180 degrees, the original coordinates AB are just going to switch signs, but we don't swap them. For a rotation of 270 degrees, the original coordinates AB are also going to be swapped, similar to what happened with 90 degrees, but this time the one that switches its sign is the variable A or coordinate A. Let's do some exercises to understand how rotations work. In this case, I'm going to take these exercises 2 and 3 from the extra practice section. These ones are not going to be in your paper. Anyway, I'm going to solve them, and please take notes as needed. Let's take a look first at the figure we have in our coordinate plane. And what I would suggest you do is let's identify the coordinates first. So the coordinates of the point S are -1, 5. The coordinates of T are -5, 1. And the coordinates of R are -4, 0. If I use this rule, then we end up with the corresponding images after rotation. So originally we had -1, 5, so we're going to swap them, but this time remember B is going to switch sign. B is 5, which happens to be at the beginning, but with a switched sign, and -1 remains as is. Okay, let me just clarify here. This is a -5 or -5. Okay, and so we go with the rest. T prime. Originally it's -5, 1. When you switch them, -5 remains the same, but on the second place, and 1 is switched to -1. Now R prime, you see that we have -4, 0. We're going to swap them to a 0, -4. You might think, oh, what about the negative sign here? Remember, 0 is a neutral number. It is neither positive or negative, so there's no need to write a negative here. -0 doesn't exist. Once you have the coordinates of the image, well, you just need to plot them. Let's see what we get. Let me use a green to plot the points. Let's begin with S prime, -5, -1. It's right here, S prime. Then we will locate T prime is -1, -5, so -1 and -5 somewhere over here, T prime, and then R is 0, -4, that happens to be here. Then once you connect, you will get this figure. And this was a rotation of 90 degrees counterclockwise of the triangle RST. Now, if we do number 3, we're going to proceed in a similar way. Let's do the coordinates of the original quadrilateral. A is located at 1, 4. Then B is located at 4, 3. Then C is located at 3, 1. And finally, D is located at 1, 2. If we follow the rule, we can see that A, B are swapped, but the one that switches sign is A. So let's do this. We have A prime is going to be 4, 1, but 1 switches sign, and it's going to be -1. B prime will be 4, 3 originally, and then it's going to be 3, 4, but 4 switches sign to a -4. And so on. C prime, it was originally 3, 1, and it is now, sorry, okay, yeah, 1 and -3. And finally, D prime should be 2, -1. Again, once you have the coordinates of the image, you just have to plot them. A prime, let's begin. I'm going to do everything in blue. 4, -1 is right here. Then we do 3, -4 over here. That's B prime. Then we do 1, -3. That's C prime. And finally, we have D prime, that is a 2, -1 right here. Then just connect. And we're going to end up with a figure that looks like this. Okay? That was a rotation starting from this point of a 270 degrees about the origin. All right, let me scroll down and do one more exercise so you know what you're doing. Exercise 9 in your front page of the worksheet begins with the triangle JKL that is located at these coordinates. Then we're going to proceed at doing a translation that goes 4 units to the left and then 4 units down. And once we locate that image, we're going to rotate that image 270 degrees about the origin. So let's begin by plotting the points. J is 2, 3, so 1, 2, 3 is right here. 1, -1 is here. That should be K. And then L is -1, 0. That is here. Okay. Let's do this triangle in yellow. And now let's continue with the translation. Okay. You will notice that the translation is 4 units to the right and 4 units down. Let's begin with J. 1, 2, 3, and 4, and then 4 down. 1, 2, 3, and 4. It ends up right here. That's going to be J prime. And we do the same thing with the rest. L, 1, 2, 3, and 4, and then 1, 2, 3, and 4. And it is located right here. And that's going to be called L prime. And the last one is K. 1, 2, 3, and 4, and then 1, 2, 3, and 4 down to make it a K prime. Let's do this in yellow again. All right. So we connect the dots. Was a little bit terrible, but now you get it. Okay. That was the translation. And now we continue with the rotation 270 degrees about the origin. I already wrote the rule for this type of rotation. So let's write the coordinates of J prime, K prime, L prime. So J prime was located at -2, -1. K prime is located at Let's figure it out. That was 1, 2, and 3, and 5 down. So negative 3, negative 5, and L prime is located at 5 to the left and 4 down. So it's negative 5, negative 4. Let's use the rule. The rule tells me that A, B are switched, but the one that switches sign is A. So J double prime is going to be at negative 1, and this negative 2 happens to be here, but switching sign, right? As a 2. Then K double prime 3 or negative 3 is going to be on the other side, but as a 3, and negative 5 remains the same number. And L double prime, we're going to swap them. We have now a negative 5 over here, whereas, oh, sorry, not a negative 5. It has to be a 5, right? And then we have a negative 4 right here. Okay, now we have the coordinates. Let's plot those points using, I'm going to use red this time. So negative 1, 2. This is J prime. K is negative 5, 3. Negative 5, 1, 2, and 3 right here. K double prime, and finally L double prime is negative 4, 5. So you go back 4 and go up 5, somewhere over here, more or less. And then just connect. Let's do this in blue. And then you end up with a triangle that goes like this. This triangle that I'm about to circle in green was the result of rotating this triangle circled in red 270 degrees counterclockwise. You will see this. This is what happened, and this is where it ends up. So that's all for today. Have fun solving the rest of the exercises, and see you next time. Thank you, guys.